In the last lecture, we talked about how to calculate summary statistics in Jupyter Notebook. In this lecture, let's talk about how to interpret these statistics, and we'll also introduce correlation analysis. Please open the Jupyter Notebook Summary Statistics and Correlation Analysis. Again, we will need to first import Pandas library into Jupyter Notebook. And let's also import our last saved NBA Games 2 dataset into Jupyter Notebook. We will compare the success rate of 2-point field goal and the success rate of 3-point field goal to demonstrate the difference between central tendency and variation. So let's first calculate the summary statistics for the 2-point field goal success rate, the FGPCT variable. Let's also calculate the summary statistics of the 3-point field goal success rate, FG3_PCT. We can see that the average success rate for 2-point field goal is 0.452490, which is about 45.25%. And the average success rate for 3-point field goal is 0.350617, which is about 35%. This means that the overall success rate of the 2-point field goal is about 10% higher than the overall success rate of a 3-point field goal. The median of a 2-point field goal is 0.4520. This means that in half of the games, teams have 2-point field goal success rate less than 45%, and in the other half of the games, the teams have 2-point field goal greater than 45%. The standard deviation for 2-point field goal success rate is 0.0056, while the standard deviation for 3-point field goal success rate is 0.00995. This means that there is greater variation in the 3-point field goal success rate than the 2-point field goal success rate. When there is greater variation, it means that there is more uncertainty, and therefore it will be harder to predict the future. We can also try to visualize the standard deviation. We can also try to visualize the distribution of the two variables by graphing the two histograms separately but side by side, using similar codes that we learned in the previous lecture. So again, we'll use the hist function to graph a histogram. But inside the histogram, we need to specify both variables, FG_PCT and FG3_PCT. We also want to specify 20 number of bins. Additionally, we would like to force the x and y axis to have the same range. So we will need to use the share x equals to true and share y equals to true option in Python to restrict the same range for x and y for the two histograms. As you can see, the 3-point field goal success rate is more spread out compared to the 2-point field goal success rate. This is consistent with our summary statistics that the standard deviation for 3-point field goal success rate is higher than the standard deviation for 2-point field goal success rate. We can also graph the two histograms in a single plot. To do so, we'll need to first introduce a new library, Matplotlib. Matplotlib provides useful functions to make more advanced statistical graph. And in particular, we will be using the pyplot function from Matplotlib library. So we'll import matplotlib.plot. We also want to import it as plt so that our code will be shorter. So in this line of code, to graph two histograms in the same plot, we will first specify the data frame name, and we'll use two brackets to specify both variables, FG_PCT and FG3_PCT. And instead of using the simple hist function, we'll use plot.hist function to graph the two histograms. Note that if we do not specify any transparency of the histograms, the two histograms may block each other where they overlap. So we can use alpha option to specify transparency. Alpha equals to 0 would be completely transparent, and alpha equals to 1 would be completely opaque. Here, let's specify alpha equals to 0.3. And again, we will specify 20 number of beans. With the function plplot under the library matplotlib, we can also add labels and titles into our graph. We can use plt.xlabel to add a label for the horizontal axis. Let's call it field goal percentage. We can also label the y-axis as frequency. Additionally, we can use plt.title to add a title to the graph. And we can also specify the font size of our title. Lastly, we can also export our graph using the savefig function. We can also specify the image format when we export our graph. So this graph will be saved in the same folder as our Jupyter Notebook. As you can see from this graph, the 3-point field goal success rate is lower in general and more spread out. In sports, we sometimes use the mean to make predictions. The standard deviation provides some idea about how confident we should be to use the mean to make predictions. In this example, we are more confident to predict that the 2-point field goal success rate is about 45% than we are to say that the 3-point field goal success rate is at 35%. We can also make graphs by a certain criteria, just like we can produce summary statistics by criteria. For example, we can graph the success rate of a 2-point field goal based on whether the team won the game or not. We can simply add a by option inside the hist function to produce two histograms. One is when the team won the game, and one is when the team lost the game for the variable field goal percentage. Additionally, we can also change the color of our histogram. Similar to when we produce histograms of two variables, we also want to force these two histograms to have the same range in x and y axis. It is interesting to see that the two histograms, based on whether the team won or lost the game for the field goal success rate, both center around 0.4 and 0.5. The success rate has slightly less variation. In sports, we are sometimes interested in the change of performance of a team or a player. We can visualize such change by making a time series graph in Jupyter Notebook. Let's graph the point earned by Detroit Pistons in the 2017 and 2018 season. The first step is to make sure that our game date variable is stored in the date format. So we will run the same code as we learned last time, just to be sure. We now need to extract the Pistons game in the 2017 and 2018 season by subsetting the data. So let's create a new data frame called Piston Games, and it is a data frame extracted from our NBA games data, but only include the observations where the nickname variable equals to Pistons and the season ID equals to 22017, which is the season ID for the 2017 and 2018 season. And let's focus only on the regular season games. And the regular season for Detroit Pistons in that season started on October 17th, 2017. So we will specify the game date to be greater or equals to 2017, 10/17. And note that for date variable, we can simply use the greater, equal, or less than operators. But when we specify the date, we need to add a quotation mark to the date. Now we can create a time series graph for the point earned by Detroit Pistons for each game over time. We will put the game date in the x-axis and the point in the y-axis. We can also save this graph using the savefig function. So as we can see in this graph, the point earned by the Detroit Pistons fluctuate a lot throughout the season, and there's no obvious pattern of the performance of the Detroit Pistons team.